Hi, today we are going to see about time response. The response given by the system, which is a function of time, then it is called time response of a control system. For example, let us consider an ammeter connecting to a system that measures a current of magnitude 5 ampere. That is, we have an ammeter, the maximum value is 5 ampere. When we start reading, the value should be increasing from 0 gradually from 0 to 5 ampere. So that gradually increasing will depends on a finite time. So that is a deflection from 0 to 5 ampere, which is depends on a finite time. This is a example of time response. Also, we may consider another example, speedometer of a bike. There is a deflection of speed from 0 to maximum speed, whatever may be the speed, maximum speed value, that is 120 or 150 or 200. By giving an acceleration, the speedometer value changes from gradually from 0 to its maximum value 150 or 200. After attaining its maximum value 150, whatever may be the acceleration given, it will not change from 150 to some other value. Its maximum limit is 150. So this is also another example of time response. Time response includes two kinds of responses. One is transient response and the other one is steady state response. Whereas transient response is a response that varies from 0 to infinity as the input varies. That is, with respect to input time, the response varies from 0 to infinity. This is transient response. Steady state response is a response at t is equal to infinity. After attaining its maximum value, final value, that is steady state response. So from this period to this period is my transient response. So at certain stage, after attaining the certain stage, whatever may be the change in input, there will not be a change in output. It attains a constant value. That is steady state response. For analyzing the system, we may have a standard test signals in practice. Here we are going to discuss about some of the test signals. One is step input, other one is ramp, then parabolic, impulse and sinusoidal input. In time response, we are going to discuss only four inputs. First four inputs, step, ramp, impulse and parabolic. While discussing in frequency response analysis, on the time we may discuss about sinusoidal input. First one is step input. It is also known as position function. Step input is also known as position function. Sorry, let me change the color of a pen. The function of step input is r of t is equal to a for t greater than or is equal to 0, whereas 0 for t less than 0. That is, if we draw a graph with respect to t as an input function, my step response will be like this. So at certain value a, my value will remains constant. This is my step response. Also, if a is equal to 1 at that time, we may call it as unit step input. That is, our magnitude value is 1. Next one is ramp input. It is also known as velocity function. Ramp input is also known as velocity function. The mathematical representation of ramp input is r of t is equal to a into t for t greater than or is equal to 0, whereas 0 for t less than 0. Here all we are considering it as positive signals. So for with respect to t, if I draw a graph, my ramp input will be like this. So the input and output is linearly increasing. this A represents a slope here, gradually increasing. So if A is equal to 1, then we can call it as unit ramp function, or unit ramp input. The next input is parabolic. Here, parabolic R of t is equal to A into t square by 2 for t greater than or is equal to 0 and 0 for t less than 0. So this is my parabolic input function, exponentially increasing function. This is my parabolic function. Here A represents a slope, that is slope is A into t. Here also, if I substitute A is equal to 1, the function or the input is called as unit parabolic input. Impulse response. That is a sudden change or instant value. It is known as instant value. Parabolic. It can be represented as acceleration input. Acceleration input. So let me come over here. Impulse R of t is equal to A at t equal to 0, whereas 0 at t not equal to 0. So at the instant when the system starts, that is t is equal to 0, when there is no initial condition, the system will have an output A. For the other values of t, the system will have an input of 0. So here also, if A is equal to 1, we can represent it as del of t is equal to 1. That is unit impulse signal, or unit impulse input. Sinusoidal input, practically we can have these input in all our system, that is sinusoidal waveform. R of t is equal to sine omega t for t greater than or is equal to 0 and 0 for t less than 0. So these are the 5 standard inputs we are going to use for analyzing a system. In control system syllabus or in control system generally we are studying, we have a derivation for applying step, ramp and parabolic. Generally, in analyzing a first order and second order system, generally we consider step input or ramp input for analyzing and for determining transient and steady state response. So we will see that in the next video. Thank you all.